In this video, we're going to go through the steps used to balance a redox reaction. And in a separate video, we're going to go through and actually apply these steps. Now, I'm going to have one reaction that I do show, well, a half reaction at least, as we go through this so that we have some idea of what would be happening in each, just so we have that to help guide our eye. But we're going to do most of the heavy lifting in a different video. Now let's look at our steps. The first thing we're going to do, we need to assign oxidation numbers in order to determine what atoms are being oxidized or reduced. Now if we already know, then those are the only ones we have to do. If we're not sure which ones are being oxidized or reduced, then we'll do them all. Now notice here, iron is at 2+, so its oxidation number is very clear. It's 2+. We come over here to the Fe2O3. We know that oxygen is going to be a 2-. I've got 3 of them. It's going to be a -6 oxidation number on that side. The whole thing is neutral. So the iron is going to be +6 to neutralize it. Divvy that up for my 2 atoms. This will be a +3 oxidation state on this side. Okay, so this has been cleaned up a little bit. Iron 2 goes to iron 3. We have that much in mind. So we're going to look at the whole reaction. Remember, I've got part of my half reaction down here. So there'd be more things that we would have done that with. But I just want that to illustrate. Now we're going to separate the reaction into 2 half reactions. And each of our oxidized or reduced agents have to have their own separate equation. So my set of oxidized molecules and then my set of reduced molecules are going to be the half reactions. In other words, I'm going to have this as a half reaction. I'm going to have whatever else is happening as a separate one. Now, you'll notice immediately that this is not a balanced chemical equation, and that's going to kind of throw you off at first, I'll bet. That's okay, though. Because we're about to do the balancing, we're going to worry about all the other atoms in a minute. The main thing is we want to just make sure that everything in our original reaction, other than things that have hydrogens and oxygens, other than those pieces, we're making sure that they're appearing here. Then we put in anything that has those and still has our key molecule of interest, our key atom of interest. In that case, we're talking about iron. Since this has iron, we're going to make sure it's present. We're not going to care about balancing the oxygens yet. We're going to deal with it in a second. Now in our next step, we're going to go through each of our half reactions. Now we need to balance the number of atoms being oxidized. We still don't care about balancing charge. We only are doing this step so far. I have 2 irons on this side. I have 1 iron on this side. I need to go ahead and balance that by getting the coefficient 2 in there. Okay, now that I have the right number of atoms on both sides, we can start to worry a little bit about charge, but only a little bit. What we're going to do is we're going to balance the electrons. I'm not balancing the whole charge, I'm only balancing the number of electrons to account for the change in oxidation number. Now why am I not doing the rest of the charge? Well, because I still have to account for this oxygen. And since I'm assuming an acidic environment, I'm going to have to do some tweaking on this in order to make it work. And that's going to throw my charges right back off. So instead we focus just on the electrons. We say that I'm going from having 2+ to having, let's see, 3+ here. And that means that I need to have 1 electron going for each of those. So right now I'm going to have 2 electrons in order to make that balance. Now hopefully that makes sense. Look at this. I have 3+. I've got 2 of that. So there's a total of +6 oxidation number on this side. There's a total of 4+ oxidation number on this side. So I'm going to need 2 electrons to account for that. That's the way that we want to go through that. I didn't say charge. I said oxidation numbers. Okay, so we balanced our change in oxidation number by putting in some electrons, which completely threw off any semblance of charge balance that we had. But that's okay because we're going to deal with it. Now we're going to balance our oxygen atoms by adding water to one side or the other. I've got 3 oxygens on this side, so I can put 3 H2O on this side. I now have 3 oxygens, balancing my 3 oxygens. So that's okay. But you say, well, wait a minute, what are you doing here? Every time you do this, you end up unbalancing yet another thing. That's fine because it's all going to work out at the end. Because the next thing we're going to do is balance our hydrogen atoms by adding H+. So I've got 6 hydrogens on this side. I'm going to add 6 H+'s over here. Okay, now let's see here. This isn't a charge, that's just an oxidation number. I've got 6 plus charges now, 2 minus charges, so I'm at plus 4 overall over here. I'm at plus 4 on this side. Hey look, things just ended up being charge balanced. And look, I've got 6 total hydrogens here and 6 hydrogens there. I've got 3 oxygens here and 3 oxygens here. I've got 2 irons there and 2 irons there. By going through all of these steps, we got a completely balanced half reaction. Now what we're going to do is combine this with its other half reaction that we've been working on in parallel. Now for that to happen, we just say to ourselves, well, what's the one reactant that they definitely are going to have in common between the two reactions? And one of them is going to be using electrons while the other one gains them. So we need to make sure that the electron number matches between the two, which means we're probably going to have to go ahead and multiply. So if this reaction here is going to be with 2 electrons and my other reaction had 3 electrons, obviously I've got to get to a point where I'm at the common number of 6 electrons. So I'm going to multiply this entire half reaction by 2. I'd multiply by 3. I'll multiply the other half reaction by 2. That gets me to 6 electrons in each of the 2 half reactions. I then recombine the 2 half reactions into a full reaction, cross-cancel anything that's in common, and simplify my coefficients. And one of the things that will disappear when I do that is the electrons themselves. Because in a redox reaction, we're transferring the electrons, but we have the same at beginning and end, so we don't usually write them. Those are the steps for balancing a redox reaction. Definitely give this some practice.